How GPS works, explained simply. You probably use GPS every day. In your phone, in your car, on a smartwatch. You tap a screen, a blue dot appears, and it instantly knows where you are. It feels simple, almost invisible, like it just works. But before we talk about how it works, it helps to know what GPS actually means. GPS stands for Global Positioning System. Global, because it works anywhere on Earth. Positioning, because it determines where something is. System, because it's not a single device, but a network working together. And once you see it as a system, everything else starts to make sense. GPS is not tracking you. It's not watching you. And it's not following your movement. GPS doesn't even know you exist. It's just math, very precise math. And it all starts far above your head. About 20,000 kilometers above Earth, there are dozens of satellites orbiting the planet. They move constantly. They never stop. And they don't communicate with each other. Each satellite has one simple job. It sends out a signal, over and over again. That signal contains one thing: the exact time the signal was sent. Not the time on your phone, not even close. This time comes from atomic clocks. So accurate that losing a second would take thousands of years. Each satellite is basically a flying clock in space. Broadcasting time, nothing else. Your phone listens. At almost any moment, it can hear signals from multiple satellites at once, usually 4 or more. And this is where positioning happens. Your phone doesn't ask satellites where you are. It calculates it. It measures how long each signal took to arrive. Signals travel at the speed of light, which feels instant, but it isn't. Even light needs time. And that tiny delay is everything. If one signal arrives later, that satellite must be farther away. So your phone converts time into distance. Satellite 1 is this far away. Satellite 2 is that far away. Satellite 3 is at another distance. Each distance becomes an invisible circle around a satellite. With one circle, you could be anywhere. With 2 circles, there are only 2 possible spots. With 3 circles, there's just one place they all intersect. That point is your location. This method is called trilateration, not triangulation. No angles involved, just distance and geometry. But there's a problem. Your phone's clock is not accurate enough on its own. If it's even slightly wrong, your position would be off by kilometers. So GPS uses a 4th satellite. That extra signal allows your phone to correct its own clock while calculating your position. That's why GPS needs at least 4 satellites to work properly. Once your phone knows where it is, GPS has done its job. It gives you coordinates, latitude, longitude, and time. GPS doesn't know about streets, or buildings, or destinations. Maps, routes, navigation, traffic all come from software on Earth. GPS only answers one question: where am I right now? This also explains why GPS sometimes struggles. Tall buildings block signals. Tunnels cut them off. Dense forests weaken them. When signals are missing, the math has less information to work with. So the blue dot starts to drift. Not because GPS is guessing, but because it's calculating with fewer pieces. So the next time your phone quietly shows exactly where you are, remember what's really happening. A global system of clocks in space is constantly sending time. Your device is listening, measuring tiny delays, solving equations, all to answer one simple question: where you are. Did you already know this is how it works? Did something surprise you? Or would you like to know how something else works? Let me know in the comments. Thank you for watching. Till next time.